Welcome back. Welcome back to the session. And I hope there is a clarity regarding the previous topics which we have learned as of now. I hope you have a clarity with respect to the shifting of pressure belt, specifically with respect to the shifting of sun. So as there is an apparent shifting of sun, there will be a shifting of pressure belt. There will be a latitudinal shift in the winds as well. I hope you have a clarity with respect to this particular aspect. We have covered this thing in our previous session. I hope you have a clarity with respect to the secondary circulation. These are the highly localized phenomena: land breeze, sea breeze, mountain breeze, valley breeze. Likewise, let's have a quick recap regarding the distribution of pressure belts, that how there could be a shifting of pressure. So technically, this is how we could have what we could have a like a resemblance. This is what the resemblance in which how we could have a shifting of pressure belt. So see guys, here we have the position of sun, and now you have to tell me if this ITCZ stands for what? ITCZ stands for Intertropical Convergence Zone. It is basically the zone at which the winds are actually converging. So here, for example, we have a 30-degree south. Here we have, for example, 30-degree north. From this high pressure to we have this zero equatorial low pressure. So we have a winds. So this is what the aspect of convergence. The winds, those who are coming towards each other, when they will come, they will heat up, they will rise. So this scenario is being known as what? Convergence. So we have a convergence of high from this high pressure towards this low pressure. That's how the zone is being known as what? ITCZ, Intertropical Convergence Zone. It is same as that of equator. When we have an equator-like condition, so that equator-like condition in terms of isobar being known as ITCZ, Intertropical Convergence Zone. So how it will going to be formed? See, focus, pay attention guys. When sun is in the southern hemisphere, or let's say when there is some sort of situation with respect to the winter solstice, when sun is here on roughly, let's say on this particular, we can say, tropic of Capricorn, as a result of this there will be a heating. When we will have a heating, we'll have a maximum angle of insolation which could be here. As a result of maximum insolation, we will have what? Low pressure, correct? Contrastingly, with the other latitude, what would happen based on the land features as well? I hope you have a clarity. Which part of land will going to absorb, which part of land will going to have a high pressure, which part of land may have some sort of low pressure. Desert will have a low pressure because it is going to absorb the more. When it comes to this particular cooler latitude, here we have ice, more albedo, reflection will be there, absorption will be less. If absorption will be less, low pressure might not be there. Then we have a high pressure, thermal contrast. I hope you remember. So based on the thermal contrast, we could have a high pressure, we could have a low pressure. So here we have what? This low pressure. Now contrastingly, on equator we have what? Low pressure, okay, in usual condition, but now this low pressure has actually shifted. Similarly, correspondence to this, here you will see that we used to see this. These are the isobars, okay, and based on these isobars we used to draw a pattern that, okay, this is the pattern in which we have what? High pressure, okay, this is the zone, you can say this is the zone, and we used to say this is the high pressure belt, this is the subtropical high pressure belt. That 30-degree north and 30-degree south will have high pressure belt. So this high pressure belt is actually the zone, and that zone is actually being formed based on the connecting the same sort of isobars which are there on the earth's surface. And how these isobars are there? Based on the heating and cooling. Clear? All right. So here we have a high pressure, and here you can see that with respect to the southernward shifting, the high pressure which used to be there, let's say this is the actually the Cancer, roughly here, let's say we have a 30 degrees. So the high pressure which used to be here, now the high pressure zone, or let's say the high pressure which is there, now this high pressure would going to shift. Actually it used to take place in this way, okay, clear? And from this high pressure, winds will move towards the low pressure while following all those rules about which we have already discussed. Trade winds, if it is there in the tropical area, okay, or if it is there in the high pressure, low pressure, trade winds, northeast trade wind, southeast trade wind. Westerlies, if it is in the subtropical high pressure to subpolar low pressure. If it is subtropical high pressure to subpolar low pressure. Okay, easterlies if it is from subpolar high pressure to subpolar low pressure. Sorted. So technically we have a pattern of isobars in this. Okay, we have a pattern of isobars in this way, and yes, wind will blow while following the pressure gradient with respect to the general rules of deflection, etc. Here you can see that the winds are actually some sort of what? Winds are actually not, winds will actually blow, or let's say, suppose we have a isobar, we have a high pressure for example, and here we have a isobar which is low pressure actually. So based on the pressure gradient, we will have what? Wind which will going to blow. So what you can say, that wind used to blow with respect to the perpendicular position to the isobar. Wind is always perpendicular between two respective isobar. But when you are here, for example, so here what will happen on the polar region, when it comes to the isobar, wind will also going to blow parallel to the isobar. Why is that so? Because here, I hope you remember, with respect to the wind deflection and wind speed, here we have a homogeneous surface. Here we have a homogeneous surface. The cool conditions are existing, and that's how, when we have a homogeneous surface, the pressure belts which are actually formed, they might not that much intense. As a result of that, pressure gradient may be weak. If pressure gradient is weak, we could have a geostrophic wind in these polar parts. And here we have a geostrophic winds. Geostrophic winds are actually parallel to the isobar. Clear? About geostrophic wind, you'll have a clarity in a while. Got it? So this is how we have a pressure belts. Here, okay. Here if you see, for example, this is the scenario of low pressure. Imagine, just see these two diagrams contrastingly. Here the high pressure is there, high pressure is here, high pressure is here, but here the high pressure is slightly modified towards the northernward. Okay, so this low pressure which used to be here, now that low pressure is suddenly shift northernward. Why? Because sun is northernward, because sun is actually moving northernward. So here, let's say here roughly on this particular latitude, Tropic of Cancer, we have a sun. If we have a sun here, what would happen? The pressure belt will going to shift, and here you can see that this is what the Capricorn. So here on 20 degrees south we have what? High pressure. Okay, here roughly you can say that based on this, what you can say, that around 25 degree north we have what? Low pressure. The same low pressure which used to be there on equator, or the same low pressure which we have seen in the previous slide in terms of ITCZ. So we have a shifting of pressure. We have a one thing for sure, as there is a shifting of sun, we have a shifting of pressure belts. So pressure belts are also dynamic. Sun movement is dynamic, pressure belts are also dynamic. As the pressure belts are dynamic, winds will have some sort of change in terms of their orientation. Here if you see, for example, we have what? Low pressure here, and from this low pressure here we have what? High pressure. So wind will follow the gradient, and when wind will follow the gradient, here if you see for India for example, so winds are like what? Winds are like what? Winds are like sea breeze. Winds are coming from sea. At a local level, if you see, here we have a sea breeze. This is what? Sea breeze. Contrastingly, if you see here, so what is wind? Wind is actually, let's say in this way, wind is actually moving, for example. So wind is what? Wind is originating on land. So here we have what? Land breeze. When we have a sea breeze, for example, in this way, when we have a sea breeze, for example, in this way, so as a result of sea breeze, what will happen? There will be a moisture on Indian landmass, moisture on Indian soil. When we have a moisture on Indian landmass, we have a monsoon, we have a rainfall. I hope you have a clarity that when there is a shifting of pressure belt, in between the pressure belts, the winds, those who are blowing, their orientation with the land will also going to change. The latitudinal zones over which wind used to blow, that zone would going to change throughout the year. And I just gave you the example of India. So similarly, winds here, this is the scenario of monsoon, for example. Okay, just try to understand this thing. So as there is a shifting of pressure belt, we have what? Weather activities, we have what? Redistribution of heat, we have a redistribution of moisture, and all of these activities are governed by shifting of sun, shifting of pressure belt, shifting of wind with respect to the land masses, alignment or orientation of wind with respect to the land mass. Sometimes they could be sea breeze, sometimes they could be land breeze. Clear? All right. So what we can say, this pattern of planetary winds is largely dependent on what? The pattern of planetary wind is largely dependent on latitudinal variation of atmospheric heating, emergence of pressure belt sequence. There is a proper sequence, and as a result of emergence of pressure belt, there will be a migration of pressure belt in accordance with the position of sun. The distribution of continent and ocean is also responsible. That would lead to what? Sea breeze. I hope you remember sea breeze and land breeze. Rotation of earth is also playing a role, Coriolis force. And yes, the pattern of this movement of planetary wind is also called as what? General circulation or primary circulation, about which we have already discussed, and now we have actually conceptualized this thing on our world map. So I hope there is a clarity with respect to this thing. In our previous session, or let's say in our last session, we discussed about this thing: land breeze, sea breeze, mountain breeze, valley breeze. Okay. So when we have what? Warm air will have what? More temperature. When we have a cool air will have a less temperature. It's a general thing, okay, for sure. And when we have a sea breeze, for example, so this sea breeze is what? Some sort of, you can say, have a moisture, or let's say it will be wet. So as a result of this, as there is a water in general, so here it will lead to what? Moderating effect. Okay, moderating effect. And when we have this land breeze, for example, so land breeze will be what? Land breeze will be dry, because it is originating on land. There is no water, or let's say there is no moisture in this air, or in this particular wind. Why? Because it is originating on the land itself. It is originating on land itself. Whereas if you see the sea breeze, so the sea breeze is originating on sea. So when there is a heating, just a minute. So when there is a heating, as a result of heating, what would happen? Water will warm and air will warm. So when air will warm, when water will warm, as a result of warming of air, pressure gradient will be there, differential pressure belt will be there with respect to this. And when we have a moisture, so that moisture will be taken by wind with respect to the this way, from sea to land it will take. So that's how we will have a moisture here. But this situation will be reversed here, as the wind is originating on land part, and on the land, whenever there is a warming, only the air will warm. So air will not have moisture usually. There is no moisture, for example. So air is what? Dry. So dry air will move towards the ocean or towards the sea. The same assumption I hope you can apply here as well. Here, with respect to India, this is land breeze. So if we have a land breeze, here we will have a dry condition in the coastal area. Here if we have a sea breeze, so we will have a moist condition here on the coast of India. Now this can be understood, I hope, with respect to the shifting of pressure belt. As the pressure belt will shift, the confluence of winds with respect to the landmass, with respect to the coastline, with respect to the continents, with respect to the countries, would going to significantly change.